Hi, I'm going to show you in this video how to create a double swing door family in Revit. So let's get started. I'm going into File, New, Family. I'm going to choose a door template. It's very important that you choose the correct family template for all the new families that you create. In this template, there are already a few parameters that are provided to you. You have to check if you need all of them, or are you going to use only some of those? Here, I can see that there is a frame projection, exterior, interior, and width parameters. They belong to these geometry that is created in the template. This is not in my design, so I'm going to remove this geometry. And along with that, I'm also going to remove the parameters that are associated to that geometry. Apart from that, there is a width and height parameters which I need. These parameters belong to the opening that has already been created. So before starting a family, you can adjust these height and width parameters to the ones that you need. And make sure that your opening widths and heights are correct. Of course, because these are parameters, you can always modify them and edit them in a later stage of the family. So there's these few reference planes that are also provided to you in the template, which we are going to use in our project. Now, the design of the door is already drafted in this case in AutoCAD. For this may be the case for you, or this may not be the case for you. But I'm going to use this drawing as a reference so that it's easier for us to take measurements. I'm going to insert, import CAD. I have already prepared this file for import by removing any unnecessary elements from the AutoCAD file. I'm going to make sure that this particular import is viewed in the current view of exterior only. I don't want to see this imported file on all views. So I'm going to make sure that I select the current view only option. I'm going to open it. Now I'm going to place it in a position that the center of the imported file and the center of the reference plane of the center reference plane matches. Of course, because it's pinned, I have to unpin this first and then move it. So you can see that we have some reference to begin. Now, the first geometry that I'm going to begin with is this outer frame. Now, because this is a C type of frame, I'm going to use sweep for creating this geometry. So I'm going to reference level, and I want to place this frame in the center of this wall. So I'm going to create and set my work plane by picking a plane to the center of the wall, but I'm not going to choose the center of the wall here. Instead, I'm going to choose the this reference plane that has been created here in the template. Going to the exterior view, and now I'm going to use sweep by sketching the path, and I can pick the path the same line as of the opening. I'm going to lock it because I want to make this parametric. I want this frame also to move along when I change the width and the height of the door. So I'm going to lock this alignments. And my path is now a C shape. I'm going to say finish and edit the profile. And you can see that there is a reference plane provided here. So I'm going to use that as my reference. Draw your profile at this red point where it is provided to you. Now the measurement is about 75 by 75 millimeters. So you can also use formulas if you don't want to calculate. You can say 75 by 2 or any other formula in this case. 75 by 75. So I'm going to use this dimension and I'm going to trim this edge here. So I have a 75 by 75 of grid square, which is going to be extruded along the path. So I'm going to finish this, and I'm going to go into my 3D view to see my geometry here. Now, you're working with the parametric family, it's always best to always check whether your geometry is flexing with your parameters or not. I'm going to do that here. I'm going to change these parameters to 2800 and 1500, and you can see that the geometry moves with it. Along with this, I'm also going to create a parameter for its material. So here in the properties, when I select this geometry, there's one option to directly give the material, but I'm not going to choose that because I want this material to be parametric. So I'm going to associate this family parameter to a parameter called frame materials. And I'm going to make this as a type property. Say, okay, okay. So if I go here in the frame material and I change the material in the parameters, let's say I'm going to duplicate a default material and call it wood frame. And I'm going to choose a material that is wooden materials. Let's say, for example, cherry wood. And the graphic color is this here. So I'm going to say okay. And if I change this information here, you can see how the model also changes with it. Let's go to the exterior view. Now we have this outer frame. Now what we need here, I'm going to put this back to 1200 and 2600. What we need here is the horizontal frame here, which is the division between the vent and the panel here, door panel here. I'm going to measure how much that is. It's 50 millimeters. I'm also going to again use sweep for this. I'm going to sketch the path and I'm going to make this here. Now, in this case, I'm making it fixed to 250 here right now. But if you want to make it parametric, what you can do here is you can create a reference plane. The shortcut is RP for reference plane. You can also go into create and choose a reference plane from here. And I'm going to use the dimension tool to create a dimension between these two reference planes. We'll give this dimension into a parameter called plane offset. Like that. You could call it any name that you want to give. Now, if I change this to, let's say, 250, you can see how the reference plane changes. So now I can go into sweep, I can go into sketch path, I can use my line tool, and I'm going to choose this reference plane, align this reference plane with this, and lock it. The alignment lock is very useful when you're working with families because they allow you to connect the geometries with the reference planes or any other geometry as well. So connecting geometries with the parameters, these alignment locks is wonderful too. So I'm going to finish this and edit the profile in the left view here. Now, because you can see that this reference plane is at the top of this frame which you want to create, the profile has to be below this red point here. So I'm going to go into the left view. I'm going to create a profile that is 50 millimeters in height and 75 millimeters in its width. I'm going to finish this, and I'm going to go into the 3D view. And I'm also going to assign this as the same material as the frame, so I'm going to call this frame material. And of course, you can always check this before you move forward. If you find an error at the end, it's going to be very difficult to identify where the error was. So it's when you're creating parametric families, always good to flex your parameters and keep checking on your family whether it's working as per your expectations or not. I'm also going to change this offset and make it, let's say, 500 and see whether it's working. Yes, it is working. Wonderful. So I think my imported file is a bit off, so I'm going to correct that. Okay, so the next step is to create this internal frame of the glass panel at the ventilation here. So I'm going to measure that, how much that is. So this is 25 by 25 of rectangular frame here. So again, I'm going to use sweep for this. So I'm going to create and go into sketch path and create a rectangle. And of course, I'm going to lock, and lock so that they also get connected to the width parameter. So I'm going to move this reference plane to the horizontal level so that we can draw in plan view. I'm going to finish this and edit the profile in the plan view where the red point is. So this is 25 by 25, so I'm going to make it 12.5, 25, 12.5 again. Oh, sorry, I could have directly said 25, but nevertheless. And finish this. I'm going to look at that in 3D. So you can see that there is an internal frame here, which again is the same material as the frame material. So I'm going to associate that to the frame material parameter. Okay. So the next step is to create a vertical frame here. Again, the 25 by 25. So let's go back to sweep, and I'm going to use the center line here. And I'm going to make sure that I do use align and lock option so that it's aligned to the center reference plane. It remains equal when we change the width of the door. I'm going to finish this and edit my profile and go into the reference plane. I'm going to make this rectangle here. I could start with any shape, and I'm going to change the dimension to 12.5 on both sides, so that its total is 25. 12.5 here, 12.5 here. Finish, go into the 3D view. And if I now try to change the width of this, you can see that this remains in the center. I can also try to change the offset here and see if this gets stretched enough to meet the frame. And everything seems to be working all right. I'm going to put it back to what it was. Change the material to the frame material here. I'm going to say okay. So far, so good. Now let's move on to the next step. I'm going back to the exterior view. Now I have this rectangular frame for the door here. Okay. And the measurement for that is about 50 millimeters. I'm going to use a 50 by 50 rectangle as an indication of that frame. So again, I'm going to create sweep sketch path, and I'm going to use a rectangle here and lock, and lock. These are all alignment locks. So, and I'm going to move this reference plane in the horizontal direction so that we can draw the profile in the plan view. And I'm going to say finish, edit the profile, go into the plan view, and find your dot, red dot. I'm going to draw this as 25 by 50 by 50. And trim this two lines here. I'm going to say finish, finish, and 3D. This is the internal frame, and I'm also going to assign this as a frame material. And of course, let's check if it's working all right. So I'm going to change this to 1500 and height to maybe 2800 and apply. And you can see that it is still parametric and it's working all right. So let's put it back to 26 and 12. Going to the peer review, and now we need to create these vertical and horizontal lines here, vertical and horizontal frames. So let's get started by creating the horizontal frame first. So I'm going to create sweep again, sketch the path, and I'm going to use this here. Now again, this could also, let's not directly create a sweep. Let's create this as a parameter. So I'm going to create a reference plane here so that we can control this. And I'm going to call this dimension as upper panel offset. You could name it whatever is more convenient to you. And now I'm going to create sweep, sketch the path, and I'm going to draw this line here. I'm going to make sure that I use align and lock here so that this sweep is going to move up and down based on how much offset you have defined. I'm going to finish this, edit the profile, go into the left view here, find my red dot, and draw a rectangle of 50 by 50. So this is going to be 25. This is going to be 50. Already 50. I'm going to finish this, and go into my 3D view. I can flex this parameter and check upper panel, let's say 1200. You can see how it moves up and down here based on the offset. So let's add the material to it by creating this as a frame material. Let's go back into the exterior view. Oh, I think we had to draw this at the bottom of this. I'm going to edit the sweep, select my profile and edit this. So we actually wanted this below our red point. Let's try to change that and see if it's correct. Yes. You can always edit your geometries after you have created them if you would like to make any changes to that. So now it's time for vertical frames. So again, I'm going to use create and sweep. You could also use extrusion for these cases, but I like to use sweep because then you have more ability to align your sweep paths with the reference planes, and it's more robust when you're working with parameters instead of extrusion. So I like using sweeps more than the extrusions. But of course, it's a personal choice, and you can also try alternative methods. So I'm going to align and lock this and finish this here. I'm going to edit the profile. I'm going to create 100 by 50. Trim this part. Finish this, go into the exterior. So you can see that we've created one part of this frame. I could also have created two continuous 200 millimeters frame. If that's your choice, you can also do that. If you want two frames like this, you could go and mirror this up here using this reference plane, and you can have two objects here. So depends how you would like to have your family. It's up to individual choices. So I'm going to use these two frames and add the material to it. And these overlaps can be removed by using join geometry. I'm going to join this, and you can see how clean joints we have now. And of course, let's flex it. We would like to make this 1500 and this is 2800 and this is probably 1200. This is 500. Let's see what happens. Everything works all right. So I'm going to undo this and make it back to what we had. So now it's time to add glass panels here and the wooden panel here. So I'm going to use extrusion in this particular case, and I'm going to make sure that my reference plane right now is at in the middle of my plot. I'm going to use extrusion, and I'm going to use rectangle here. Lock, 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 and lock, so that it flexes with all the parameters we've created. And again, I'm going to create another rectangle. Make sure I use all the locks on all the four sides. I'm going to also use this extrusion start and end option. So I want my glass panel also to be exactly in the center of the frame, which is in total 10 millimeters thick. So I would say that it is -5 from the center and +5 from the center. So you can see that this extrusion is sitting in the center now. So because we chose this as our work plane, it is -5 in this direction and +5 in this direction. So you have extrusion start and end that defines the thickness. So let's create a material for this. So again, I'm going to use an associated parameter, but this time I'm going to create a new material. Print panel materials. You say okay. Okay. Go into the family types here. Choose, let's say, glass option. Okay. Okay. And you can see how this changes. Let's see if everything works all right. 1500. Yes, it works all right. So let's change. I'm going to repeat the same process for these two panels here. So I'm going to create extrusion and I'm going to lock, lock, lock. I don't want these parameters. Let's do it again. Rectangle. I'm going to lock here. I'm going to lock this one, this side as well, and this side as well. Again, another rectangle. Again, this extrusion start is -5, extrusion end is +5. So the total thickness is 10 millimeters. I'm going to say finish. Go to 3D view and see if it's in the center. Perfect. So I'm going to add the material to it, call it a new material called door panel material. So this is again a parametric material. You can always change it inside your project if you would like to do that. Say okay. And the same process for the bottom two panels. Because these have different materials, I've chosen to create a different extrusion for it. But if you also have glass panels, you could use the same extrusion and add create 4 panels in the same step. So I'm going to use create extrusion. I'm going to use a rectangle here, lock it, lock, and lock. And lock, lock, bottom also locked. You can zoom in a little bit if something like this happens to find your lock properly. And in case if you miss the lock and you would like to do it later on, you can use the alignment lock. So you can align and create a lock. I'm going to use finish and look at it in 3D view. So far it looks all right. So I'm going to use this material as bottom panel. All right. Now this one I'm going to call it, I'm going to modify the parameter and call it upper panel material. And this one is the bottom panel material. I'm going to say, make this, I'm going to duplicate this and call it wood panel. And we'll change a different, something like this, an ash tone. Okay, all right, okay. So let's see if everything is working as per our expectations. Randomly choose any numbers for now. Let me see if things working. Perfect. So let's put everything back to what we had. Wind offset was 250, upper panel offset was 1050, and height is 2600. Go into exterior view here. Okay, so the next step is, now we don't need the AutoCAD reference on the back, so I'm going to remove it now. So the next step is to create symbolic lines on your door. Now, when you load the door in your project, normally in architectural drawings, you want to show how your door opens up in which direction. But when you look at it in the 3D or exterior view, you actually want your door to be closed. So from the plan view, you want to remove the visibility of these particular objects, and instead you want to create a symbol which shows that in which direction your door actually opens up. So to do that, I'm going to use a tool called visibility settings. So I'm going to select the objects that I want to remove from my plan view. You can also do this in 3D view, it's much easier. I'm going to hide the element temporarily. The shortcut is H, so I could use this opening. H, so it gets removed, it gets hidden from this view temporarily. So I want to see this outer frame, so I'm also going to hide that. I don't want to see these frames here from my view, from the plan view. So I'm going to just select the objects from there. I'm going to use visibility settings. And here I can decide whether this geometry is going to be visible in plan view, front view, left, or left, front and back, left and right, or when it is cut in a plan view. So I want to see them in elevation and sections and 3D view. So I'm going to keep this on, but I'm going to remove this two options. So when it's in a plan view and when it is cut in a plan view. So in both cases, please hide this particular geometries. And we'll say okay. And I'm going to choose these frames as well. And I'm going to go into visibility settings. Okay. And go into yes, okay. I'm going to hide this as well. I'm going to use these extrusion panels and going to visibility settings and change that too. So hopefully I have done this for all objects. In the family plan view, you will see that this is grayed out. In the actual project view, and when you load this family into a project, this is going to be hidden. But in a family environment, you will see this to be grayed out. So you can see when I turn on the thin line options, the line weights are on. This is more clear here. So now I can go into annotate symbolic lines, and I'm going to draw center ends arc here. It starts from the center, goes to the center, and stops here. I'm going to draw this here. I'm going to do the same in this direction. I'm going to always make sure by flexing my width whether these arcs also move with the parameters. So far it looks all right. Let me try reducing the size and see if it works. It's working. Everything seems to be working all right. I'm going to save this particular family as door. I'm going to save it. Now, the next thing what you can do additionally to this is create family types already in your family environment. So if you already know the sizes of the doors that you're going to use in your project, you can go here into the family types and create a new type. I'm going to call it 1200 by 2600. So that's the one that we are going to use. And then there's another type, which is, let's say, 1500 by 2600. So in this case, I'm going to use width as 1500 and upper panel offset as, let's say, 1200. Okay. And then I'm going to create another type called, let's say, 1800, or let's say smaller size probably. So let's say 1000 by 2300. So width is 1000, height is 2300, and this is 1000. Okay. You can see that when I change this to 1200 by 26, everything changes. 1500 by 2600, everything changes. And when I now create a file new project, create a dummy wall here for now. And I'm going to save this family and load it into the project. So you can see that in the plan view, you are not able to see the geometry, which we hid it. You can only see the frame and the symbolic line that we created. When you flip your door using these arrow keys, your symbols are also going to get flipped. In the elevation, you can see the door with all the geometry in it. See that 3D view. I can also select this door, and if I go into the type properties or type selector, you can see that there are 3 types already available here. And I can always change this to a different type. And if I would like to still customize any of these sizes, then I can edit the type, duplicate, and create a one more size. For example, if I want to create 1800 by 2600, I can always have that. So let's go back here. So this is basically how you can create a double swing door, which is completely parametric. I hope you enjoyed learning from this video. Like the video and subscribe the channel. Thank you very much. Bye-bye.